All right, in this lesson, we're going to look at spherical geometry. Geometry is an example of non-Euclidean geometry, so we're going to look at some of the concepts of spherical geometry, and they're going to be completely different from the geometry that we have been studying. And when we look at this, we need to remember that there is truth that we know, and then there are theorems and theories that are not proven. And so we just need to remember that as Christian, that scripture is the only absolute source of truth. So if if you see other doctrine or you see other things that do not come from scripture, you need to remember to go back to the scripture as your source of truth, and make sure that you reference scripture and you go back to scripture, versus if you read a devotional and it says something in that devotional, you need to make sure that the truth comes from scripture and it's not just something nice that somebody said. It might sound nice, but you need to make sure that you get your truth from scripture. So just keep that in mind, and let's look at this non-Euclidean geometry called spherical geometry. And actually for it is called Riemannian geometry. So Riemann was a mathematician, and so this is called Riemannian geometry. He also might have heard later, if you ever study calculus, you will also hear of Riemann sums. So that name will be repeated in different courses. It's called spherical geometry versus Riemannian geometry. It's the same thing, but people refer to it as spherical geometry because it's represented with a sphere. So we talked about the great circle of a sphere, and in spherical geometry, great circles, which means that, remember, those are the circles that contain the center of the sphere. They're not circles in spherical geometry. They're lines of the plane, and then so the great circles are lines, and then the spherical surface, so like the outside of the sphere, that whole thing, we consider it the plane. So it's almost going from 3D to 2D, right? So the circles become lines, and then that three-dimensional shape becomes a plane. So since all great circles intersect, that means that there's no parallel lines in spherical geometry. In spherical geometry, a circle can be considered a line if it has the same radius as the given sphere. That's how you know it is a line, is that the radius is going to be the same as the sphere. And also in spherical geometry, the sum of the measures of the angles of a triangle is never 180, which in the geometry that we study, we know that the angles of a triangle do add up to 180. All right, so this is the information you need to know so far, and we will look more into this week.